Welcome to this scientific lecture on artificial intelligence-discovered recipes and dishes. Today we're going to explore how machine learning algorithms are revolutionizing cuisine through rigorous computational analysis of flavor compounds, molecular interactions, and sensory perception. Let's begin with the fundamental scientific principle behind AI recipe discovery, the flavor network hypothesis. This hypothesis states that ingredients sharing similar flavor compounds are more likely to create harmonious pairings. Imagine a network where each node represents an ingredient. The connections between nodes represent shared, volatile organic compounds. Tomato and basil share multiple compounds, which is why they pair so beautifully together. Modern AI systems analyze over 1,800 distinct flavor molecules across more than 10,000 different ingredients to discover novel combinations. Let's examine the first AI-discovered recipe, dark chocolate combined with blue cheese and strawberry. This sounds unusual, but the science is remarkable. The AI predicted an 87% flavor compatibility between these three ingredients based on shared aromatic compounds. The key lies in shared compounds. Both blue cheese and strawberries contain significant amounts of 2-heptanone and various methyl ketones. Dark chocolate contains complementary phenolic compounds. Chocolate has over 600 flavor compounds. Blue cheese has 350, and strawberry has 400. They share 45 common molecules, creating a surprisingly harmonious flavor profile. Now let's examine this from a molecular gastronomy perspective. We need to understand the Maillard reaction products and how they interact. The Maillard reaction occurs when amino acids react with reducing sugars under heat, producing hundreds of flavor compounds. The optimal temperature range for Maillard reactions is between 140 and 165 degrees Celsius. The second AI discovery is miso-butterscotch glazed carrots. This combines umami from fermented soy with sweet caramelized notes. Fresh carrots are glazed with a mixture of miso paste and butterscotch. The fermented notes of miso enhance the natural sweetness of caramelized carrots. Miso contains approximately 1,200 milligrams of glutamate per 100 grams, providing intense umami flavor. Umami intensity equals glutamate concentration times the synergy factor from nucleotides. Let's do a back-of-the-envelope calculation to estimate the flavor enhancement. Carrots have a base sweetness of approximately 15 degrees Brix, which measures sugar content. Caramelization adds approximately 8 Brix equivalent in perceived sweetness through complex sugar transformations. Umami from miso enhances perceived sweetness by a factor of 1.4 through cross-modal interactions. The total perceived sweetness is 15 plus 8 times 1.4 equals 32.2 Brix equivalent. This is a significant enhancement. The third discovery is a coconut caviar cucumber emulsion. This showcases texture contrast and flavor layering. Coconut cream provides fat-soluble flavor carriers, caviar adds bursts of umami and salt, and cucumber contributes freshness and water-soluble aromatics. The emulsion stability is maintained by lecithin content between 0.5 and 2% from coconut. Optimal droplet size is 2 to 5 micrometers for the best mouthfeel and flavor release. Texture contrast is crucial in modern cuisine. Let's examine the science behind it. Different textures have different viscosities measured in Pascal seconds. Creamy is 100 to 500, soft is 50 to 100, liquid is 1 to 10, and burst texture is less than 0.1. Discovery 4 is turmeric honey black pepper ice cream. This combines anti-inflammatory compounds with enhanced bioavailability. The golden ice cream contains turmeric with black pepper specks throughout. The piperine in black pepper increases curcumin absorption by 2,000%. Piperine from black pepper enhances curcumin bioavailability by 20-fold through inhibition of glucuronidation. Curcumin absorption increases from 0.05% to 1% when combined with piperine. The optimal ratio is 100 parts turmeric to 1 part black pepper for maximum bioavailability and flavor balance. Let's examine the thermodynamics of flavor perception. Temperature dramatically affects how we perceive taste and aroma. As temperature increases, volatile compound release increases exponentially. This graph shows the relationship between temperature and flavor volatility. Volatility equals V naught times E to the power of activation energy divided by the gas constant times temperature. Discovery 5 uses molecular gastronomy techniques. Wasabi strawberry balsamic spherification. This creates flavor bombs with controlled release. Spheres of strawberry and wasabi are created using sodium alginate and calcium chloride. They burst in the mouth, releasing intense flavor. Sodium alginate solution concentration is 0.5 to 1% for optimal sphere formation. The calcium chloride bath is 0.5% concentration. The membrane thickness is 0.1 to 0.3 millimeters, thin enough to burst easily, but strong enough to maintain shape. Now let's discuss the neuroscience behind flavor pairing. Our brains integrate multiple sensory inputs to create flavor perception. Flavor is the integration of taste, smell, and touch. The brain combines signals from taste receptors, olfactory receptors, and trigeminal nerve to create the complete flavor experience. Surprisingly, taste contributes only about 20% to overall flavor perception. Smell accounts for 70%, and touch contributes 10%. Discovery 6 combines Middle Eastern aromatics, saffron, cardamom, rose, water, panna cotta. This demonstrates how AI identifies culturally distant but chemically compatible ingredients. The creamy panna cotta is infused with saffron threads and ground cardamom. Rosewater adds floral notes that complement the spicy sweet profile. Saffron contains over 150 volatile compounds, with saffronol being the primary aroma component. Optimal infusion temperature is 60 degrees Celsius for 30 minutes to extract maximum flavor without bitterness. Discovery 7 is seaweed caramel sesame brittle. This combines umami from kombu seaweed with sweet caramel and nutty sesame. The brittle has layers of caramelized sugar interspersed with thin strips of toasted nori seaweed and sesame seeds throughout. Kombu seaweed contains 2,300 milligrams of glutamate per 100 grams dry weight, more than miso. Caramel temperature must reach 170 to 180 degrees Celsius for optimal amber color and flavor development. The glass transition temperature of this brittle is approximately minus 30 degrees Celsius, ensuring crunchiness at room temperature. Let's quantify flavor synergy using mathematical models. The AI uses these calculations to predict successful combinations. Synergy score S equals the sum over I, from 1 to n of weight, W sub I times compound concentration C sub I. The weight, W sub I, is a function of volatility, detection threshold, and hedonic rating. Discovery 8 is lavender lemon black garlic aioli. This demonstrates how fermentation transforms ingredient profiles. The pale purple aioli contains flecks of black garlic and lavender flowers. The fermentation of black garlic creates sweet, umami notes that balance the floral lavender. Black garlic is produced through 30-day fermentation at 70 degrees Celsius and 90% humidity. S-acetylcysteine, a beneficial compound, increases six-fold during the fermentation process. The pH drops from 6.5 to 3.8 during fermentation, creating complex sweet-sour notes. Discovery 9 is coffee beet coriander reduction. This sauce combines earthy, bitter, and bright notes in perfect balance. Fresh beets are juiced and reduced with espresso and toasted coriander seeds. The reduction intensifies the earthy sweetness. The reduction ratio is 8 to 1, concentrating the flavors while maintaining balance between bitter and sweet. Betalain pigments, which provide color and antioxidants, retain 75% activity when reduced at 85 degrees Celsius. Chlorogenic acid from coffee synergizes with betalain from beets, creating enhanced antioxidant activity. Let's explore the mathematics behind recipe optimization. AI uses multi-objective optimization to balance flavor, nutrition, and cost. The optimization function f of x equals alpha times f1 of x plus beta times f2 of x plus gamma times f3 of x, where f1 is flavor score, f2 is nutritional value, and f3 is cost efficiency. Discovery 10 is mango habanero lime foam. This demonstrates the balance between heat, sweet, and acid. Light, airy foam made from mango puree with tiny flecks of habanero pepper distributed throughout. Lime zest provides bright citrus notes. Habanero peppers contain 100,000 to 350,000 Scoville units of capsaicin heat. The optimal ratio is 100 parts mango to 1 part habanero to 5 parts lime juice for balanced heat and acidity. Soy lecithin at 0.25 to 0.5% concentration creates stable foam structure. Discovery 11 is olive oil chocolate sea salt cake. Extra virgin olive oil replaces butter for unique flavor and texture. Dense chocolate cake made with extra virgin olive oil and studded with flakes of sea salt. The fruity notes of olive oil complement dark chocolate. Olive oil contains 55 to 83% oleic acid, which creates a moist, tender crumb structure. Extra virgin olive oil contains 100 to 800 milligrams of polyphenols per kilogram, adding peppery, bitter notes that enhance chocolate. 0.3% salt by weight amplifies perceived sweetness by 15% through taste receptor interaction. Looking toward the future, AI is moving beyond flavor pairing to create personalized nutrition based on individual genetics and microbiome. The AI analyzes your DNA and gut microbiome composition, then generates recipes optimized specifically for your metabolic profile and taste preferences. Over 10,000 genetic variants affect taste perception, from bitter sensitivity to umami detection. Discovery 12 demonstrates complete meal optimization, an AI-generated breakfast bowl with perfect macro and micronutrient balance. The bowl contains quinoa as a base, topped with blueberries, sliced almonds, chia seeds, and a drizzle of honey. Each component is precisely measured for optimal nutrition. The macronutrient profile is 25 grams protein, 45 grams carbohydrates, and 15 grams healthy fats. Quinoa and almonds together provide all essential amino acids in optimal ratios. The total antioxidant capacity is 15,000 ORAC units per serving, primarily from blueberries. Let's examine the specific machine learning algorithms used in recipe discovery. Deep neural networks are trained on over 50,000 existing recipes from diverse culinary traditions. Reinforcement learning algorithms improve through iterative human taste testing and feedback. Natural language processing extracts techniques and flavor relationships from recipe descriptions and food literature. Discovery 13 uses ancient fermentation, koji-aged beef with miso-glazed. Koji enzymes break down proteins for enhanced umami. The beef surface is covered with koji rice mold, appearing as a white coating. After aging, it's glazed with miso and seared. Koji proteases increase free amino acid content by 300% during the aging process. Optimal aging is 48 to 72 hours at 2 degrees Celsius for maximum enzyme activity without spoilage. Total umami compounds increase fourfold compared to conventional dry aging. Let's calculate optimal ingredient proportions using the method AI employs. The ratio R equals ingredient 1 divided by ingredient 2, which equals flavor intensity F1 times mass 1 divided by F2 times mass 2. For example, balancing sweet and sour in a glaze requires calculating the ratio of sugar to acid. If we use 20 grams sugar and 15 milliliters vinegar, the ratio is 1.33, which creates balanced sweet-sour taste. Discovery 14 is activated charcoal-coconut sorbet. This demonstrates how AI considers visual impact alongside flavor. Jet black sorbet made with activated charcoal and coconut. White coconut cream creates dramatic visual contrast. Activated charcoal at 0.5 to 1 gram per serving provides intense black color without affecting flavor. Coconut fat enables even suspension of charcoal particles throughout the sorbet. Important note: activated charcoal may interfere with medication absorption, so this is a novelty ingredient to be used carefully. Let's dive deeper into browning reactions, which are crucial for developing complex flavors in AI-discovered recipes. As temperature increases from 140 to 200 degrees Celsius, browning progresses from light tan to deep mahogany. Each stage produces different flavor compounds. The reaction rate equals rate constant K times e to the negative activation energy divided by gas constant R times temperature T. Discovery 15 is green tea white chocolate matcha ganache. This combines different forms of the same plant for layered flavor. Pale green ganache made from white chocolate infused with green tea and dusted with matcha powder. 3 forms of tea create depth. Matcha contains 20 to 45 milligrams of L-theanine per gram, providing umami and calming effects. Tea catechins create antioxidant synergy with cocoa butter polyphenols in white chocolate. Optimal temperature for ganache formation is 45 to 50 degrees Celsius to maintain emulsion stability. Let's conclude by reflecting on how AI applies the scientific method to cuisine. First, we hypothesize that certain molecular compounds create synergistic flavors when combined. Second, we experiment. AI tests millions of ingredient combinations computationally before physical testing. Third, we analyze results. Human tasters provide sensory feedback that trains the algorithm. Fourth, we refine the model. Each iteration improves prediction accuracy. The future of discovered recipes promises food that is simultaneously personalized to individual preferences, environmentally sustainable, and delicious. Today we've explored 15 different AI-discovered recipes, from chocolate blue cheese pairings to koji-aged beef, demonstrating the breadth of computational gastronomy. Each discovery is based on rigorous analysis of flavor chemistry, sensory perception, and nutritional science. Thank you for joining me on this scientific exploration of AI-discovered cuisine. The intersection of computer science, chemistry, and culinary arts is creating a new era of food innovation.